Shri Sai Ram. Welcome to the 7th session of this chapter, Motion in a Straight Line. In this session, we will be discussing about the concept called acceleration. Having studied about the motion, velocity, displacement, distance and speed, now we are going to study about yet another concept. If you can see the relation, when we have studied about distance, we have also studied about the rate of change of distance, that is speed. When we have studied about displacement, we have studied about how the displacement is changing with respect to time, that is velocity. Now, we will further discuss about how the velocity is changing with respect to time. Alright, so that we call as acceleration. So, let us go inside this session, let us get started and see what this acceleration has to say. What is acceleration? As we discussed, the rate of change of velocity with respect to time is called as acceleration. Alright, you can see this is the rate of change of velocity with respect to time is called as acceleration. Now, the velocity may increase or decrease, still we call it as acceleration. It may be positive acceleration or negative acceleration, that is other thing, but we are concerned about the change in velocity with respect to time. Alright. So, when the velocity is changing, what happens? It starts with some velocity. As the velocity changes, it attains some other velocity, right? The initial velocity will be always, if it is changing, it should be different from the initial, final velocity should be different from the initial velocity, right? So, there will be some difference. So, how much difference the velocity has attained, it may be negative or positive, by the time which it took to change that velocity is called as acceleration. Alright, once again let me say, the rate at which the velocity is changing, we have started with some velocity and then the velocity is changing. How much velocity changed with respect to time we call as acceleration. Alright, that we call as dv by dt. Actually, if it is average, we can write as delta v by delta t. As a time, if you shrink the time interval close to 0, in the same case where we have discussed about the instantaneous velocity, right? This is instantaneous acceleration and this is called as what? Average acceleration. So, we will discuss about this also. Okay, it is a vector quantity. As velocity is also a vector quantity, it has a direction. Acceleration should also has a direction, right? If you must be accelerating in some direction, that only will give you the change in velocity. If the acceleration is in the opposite direction to the velocity, what happens? Your velocity decreases. If the acceleration is in the direction of the velocity, your velocity increases. Everything we will discuss in detail. So, basically it is a vector quantity, it has a magnitude and also direction. Alright. So, if this is a velocity time graph, this y axis is giving you velocity and this x axis is giving you time, seconds, meter per second. You can see what is happening here. An object is moving with some velocity as the time is increasing. This is the velocity is increasing as the time is increasing, right? So, velocity time graph will have some slope with x axis. So, what does the velocity time graph slope will give you? Slope is nothing but the change in y axis with respect to x axis, the rise over run, right? So, what does the slope of the velocity time graph will give you? Right, it is starting with some velocity and the velocity is increasing as it moves with time. So, here the slope will give you the final velocity minus initial velocity in that with corresponding time. So, that ratio will give you what? Nothing but the acceleration. Just see, slope is nothing but the tan theta is what? Delta y by delta x. Just imagine this as the final point, this as the initial point, origin. So, just drop down. So, this will be your delta y and this will be your delta x. What is delta x? Delta x is time. What is delta y? Delta y is velocity, change in velocity. This is change in velocity, this is change in time. So, change in velocity by change in time will give you what? Nothing but v2 minus v1 by t2 minus t1. How much time it took to change the velocity? It started from 0. For example, we took the point at 3 seconds. So, what happens? 3 minus 0, delta x is 3 here. For example, here also it is cutting the y axis at 3. So, it is also changing the velocity. Here also the y axis is changing by the magnitude of 3. So, 3 by 3. Here in this example, the acceleration remains 1 meter per second square, right. So, acceleration is nothing but v velocity, velocity of final velocity minus initial velocity by the time it took to change the velocity. So, it also can be written as dv by dt as we discussed, all right. Now, let us solve an example. What is given here? The velocity of a car moving towards the east from 0 to 12 meter per second in 3 seconds. So, what is given? An object is moving with some velocity. So, it is moving from 0, it is starting from rest, it is moving from 0 and it increase it to 12 meter per second. So, how much time it took to increase from 0 to 12? It took 3 seconds. So, it is just asking the average acceleration. As you already know, as far as average acceleration is concerned, we just take the initial and final values. Initial velocity is 12, initial velocity is 0 meter per second and final velocity is 12, and how much time it took? 3 seconds it took. Just the ratio of them will give you the average acceleration, right. The solution is nothing but v1 initial velocity, okay, initial velocity is 0, final velocity is 12 meter per second, time it took is 3, the ratio of change in velocity by time will give you 4 meter per second square. This is your acceleration. With 4 meter per second square acceleration, it is moving. Because it is moving with 4 meter per second square acceleration, it could attain the value of 12 meter per second in 3 seconds. 12 meter per second in 3 seconds. It is starting from 0 meter per second. All right. Now, let us see position time graphs for the accelerated motion. This is the position time graph. As far as now we were seeing the velocity time graph. Now, from position time graph we are going to acceleration. All right. Change in position. The slope of this graph will give you what? Velocity, right. Here you can see the velocity is, the slope is changing, right. Previously, if you have seen, this is displacement, this is time, position time graph. If the graph is like this, that means what? The slope is not changing. When the slope is not changing, that means what does the position time graph slope will give you? The slope is nothing but dx by dt. Dx by dt is what? Velocity. So, here dx by dt is constant. That means velocity is constant, right. When velocity is constant, what we call as? We call as uniform motion. We call as uniform motion, right. Now, but you can see here at every point the position, the rate of change of position is changing with as the time is increasing. Here the slope is almost horizontal, that's as the time is increasing in this segment, you can see the position is not changing that much. When you go from this point to this point, the slope is changing, right. And from here to here the slope is drastic. So, you can see with the equal intervals of time, the rate at which it is changing the position is changing. So, the slope is not constant here. When the slope is not constant here, the velocity is also not constant. When the velocity is not constant, it is non-uniform motion. You will have an acceleration when you have non-uniform motion. That means velocity is changing. All right. So, here you can see the velocity is changing. So, how the velocity is changing? whether it is having a positive acceleration or negative acceleration. Let us see. It is having a positive acceleration. You can just take a tangent at every point. If I am concerned about this point, what is the slope at this point? Just draw a tangent, some angle theta, it will make angle theta. At this point you can see it will make, if it is theta 1, it is theta 2. All right, theta 2 is greater than theta 1, right. Here the velocity is increasing or decreasing? The velocity is increasing. Velocity is increasing means it is positive acceleration. There are some cases where you can see the velocity is increasing, but the velocity is in one direction, but the acceleration is in other direction. Okay, we will consider that case also. As far as this case is concerned, you can see how the slope is changing. Okay, the velocity is increasing. The velocity is increasing means it is having positive acceleration. All right, as the position is also changing, the position is changing in the positive direction and the velocity is also increasing. So, you can say it is a positive acceleration. All right. Now, you can see the position is decreasing, the change of position is decreasing. Okay, and you can see the slope. If you draw a tangent here, it is theta 1, here you can see it is theta 2. All right, here you can see theta 2. Now, when you find the value like this, here theta is greater than 90. When it is greater than 90, you can say it is having a negative velocity, right. The velocity is in the negative direction. That means the change of position, the motion of the body is in the negative direction. All right. So, here the theta is greater than 0. Now, as you come down, you can see the acceleration is negative, acceleration is decreasing. Okay, we'll discuss about it in detail at this end of this session. So, when it is concave up, then you can call as what? Positive acceleration. When it is concave down, you can call as negative acceleration. All right. Now, you can see this. What does this mean? We have just solved the example. Here the rate of change of displacement with respect to time is what? Constant. The slope is constant. That means velocity is constant. When the velocity is constant, do you have any acceleration? To have an acceleration, by definition it is the rate of change of velocity, right. Here the velocity is constant because the slope is constant. That means it is having what? Zero acceleration. All right. Okay. If the when are the cases acceleration is 0? First case where object is at rest, it is not moving. Okay. Now, the car is at rest, it is not moving. That means it does not have any velocity. It do not have any velocity, right. When it does not have any velocity, there is no idea of acceleration there. Okay. That implies velocity is 0, hence acceleration is 0. Car in uniform motion, that means constant velocity. In the third graph you have seen that the velocity is constant. In the position time graph, it was having a straight line. That means what? Velocity is not changing, it is moving. It is just moving with same speed. See how it is moving? It is moving with the same speed as long as it is moving in the forward direction. That means nothing is acting on this body. So, informally I am just telling you, to accelerate something you need to apply a force on it. Okay. The force concept will come in your dynamics part. So, I am just making you sure that to understand the acceleration here. Okay. So, as the body is moving, if you want to increase or decrease the velocity of the body, you need to apply an external force on it. Okay. If you apply the external force on it, then only you can accelerate the body. Okay. When a bike is moving, what do? You have an accelerator, right? What does the accelerator do? Accelerator will increase the speed, right? Now, when I am talking about magnitude, if the brakes, what does the brakes do? It will decelerate, right? So to accelerate or decelerate, what you are doing, you are either increasing the velocity or decreasing the velocity. Here when it is moving with constant velocity, you can say that there is no force acting on this body. When there is a force that is being acting on the body, that means it is under the accelerated motion. When there is no force acting on a body, it is under the uniform motion. It is moving with the uniform velocity. All right. So here you can say, here constant velocity means what? Initial velocity is equal to final velocity, because velocity is not changing. So that becomes what? Acceleration is 0. These two cancel out each other, that becomes 0. All right. So this is about the cases where we have the acceleration 0. One case is where the object is at rest. In the second case, where the object is moving, but it is moving with uniform velocity, constant velocity. All right. So let us see the velocity time graphs for motions with constant acceleration. So let us see the graph. Here you can see the graph where the velocity is starting with some initial velocity and it is gaining some velocity, right? It is gaining some velocity, that means it is having the positive acceleration, right? Because it is gaining some velocity. That means as the velocity, as the motion, as the object is moving, the motion is also in the same direction as acceleration, right? Here I am applying force. Acceleration, the direction is the direction of force, right? The body is moving in this direction and the force is being applied on this direction. That is the reason it is, the velocity is being increased. All right. So the same thing. Now you can see how, why I call this as a constant acceleration. Take the slope at any point here. The slope is constant throughout. Any point it is same angle theta. So the slope is constant. It is a straight line. Slope of velocity time graph is straight line from where the acceleration is constant. Okay. As far as the motion is concerned, it is moving in the same direction, in the positive direction. As far as the graph is concerned, it is moving away from the positive y axis. That means the positive value is increasing. That means it is having the positive motion and also the positive acceleration. All right. If the motion is in this direction, the force is being also applied in this direction. That is the reason it is able to push the velocity even more, increase the velocity even more. All right. Motion is in positive direction with positive acceleration. Now the second graph. Now you can see the velocity is decreasing. The acceleration is still constant. The velocity is decreasing. That means it is having negative acceleration. Take any theta value, It is theta greater than 0, greater than 90. When theta is greater than 90, this is acceleration. Acceleration is negative. This is velocity time graph. This is acceleration is negative, right? Why acceleration is negative? Because the slope is greater than 90 degrees. Tan theta in second quadrant is negative. Now you can see the body is still moving in the positive direction. The body is still moving in the positive direction. It is above x-axis. It is above x-axis, right? It is in this quadrant. Now the body is still moving in the positive direction. But how? The velocity is decreasing. Slowly it is decreasing. Why it is decreasing? Because the acceleration is in negative direction. Okay. The body is moving like this, but the acceleration, the force is being applied on the body is in the opposite direction. That's why it is having some initial velocity. As the force is opposing the motion, it is slowly decreasing. It is slowly decreasing with some final velocity which is less than the initial velocity. Understood? So here you can see the body is still in positive direction with the negative acceleration. That is the reason here the velocity is decreasing. Okay. Now you can see here what is happening. Here you can see the velocity is in the negative direction and the acceleration is also negative. Now you see whether the speed is increasing or decreasing. In the previous example, you can see speed is nothing but the magnitude of these points. We are not concerned about it is plus or minus, we are concerned about the magnitude. Here the magnitude is decreasing here because acceleration is acting in one direction, motion is acting in other direction. So when you have two opposing direction, you will have the decrease in the what? Speed. Now you can see in this graph, here the motion is in the negative direction. The motion is in the negative direction. The acceleration is also in the negative direction now, right? Because the slope here you can see the slope is theta greater than 90. Then what happens? Acceleration is negative. When the acceleration is negative and also the velocity negative, what do you expect? You expect the speed is increasing here. See here, for suppose this is minus 1, minus 2, minus 3, minus 4. What is happening here? The velocity is increasing from 1 to 4 in negative direction. Okay, don't see minus 4 and minus 1 as a whole number. Minus is only giving you what? Is only giving you the direction. Okay, the magnitude you must focus on 1, 2, 3, that is the speed. Now here acceleration is in the negative direction, velocity is in the also same direction, so it will increase the speed. But according to our difference, it may be in the negative direction. I may say right is my positive, left is my negative, but that is my point of reference. But as far as the body is concerned, its speed is increasing when the acceleration is acting in the same direction of the motion. So we can deduce that motion is in negative direction with negative acceleration, but speed here is increasing. Speed is nothing but the magnitude of velocity. All right. Now one more interesting case. See here what is happening. You can see the body started moving in the positive direction. Okay. Acceleration is always negative here because theta greater than 90, acceleration is negative for the velocity time graph. All right. Here the velocity is keeping on decreasing. It went because the acceleration is opposite direction. The acceleration is acting on this body. So it is coming, it is moving with some velocity, came and it came to halt at some point. That point is t. At that point it is having a zero velocity because accelerated force is in this direction, acceleration is in this direction. So it is moving in the positive direction, acceleration made it stop at one point, that is t. After that what happens? Because the acceleration still is in this direction, it starts moving in the opposite direction along with the acceleration. Okay. Then what happens? It moves in the negative direction. Now you can see the speed is slowly decreasing because as acceleration and velocity are opposing each other up to here. Acceleration and velocity are opposing each other up to here because velocity is positive here, acceleration is being negative. From here to here you can see the velocity is also negative because it is coming back and acceleration is also negative. When both are negative, now you can see the speed is increased. The speed is increasing. It may be 1, 2, 3, 4. The speed is increasing. Okay. So here we can say one thing. When acceleration is positive and velocity is negative, speed will be what? Speed will what? Decrease or increase? Decrease. Okay. This is one condition. Another condition, if acceleration is negative, velocity is negative, then speed increase or decrease? Increases. Or otherwise you can say If it is both are positive also, the speed increases. So you can say when acceleration and velocity are of the same sign, that means same direction or same sign, same, then speed increases. When they are of different signs, that means velocity can be negative here, velocity can be positive, and acceleration can be negative here. When acceleration and velocity are different signs, when they are of different signs, that means different direction. What happens? The speed decreases. The speed will decrease. All right. So from this graph, what we can say? Motion of the object with negative acceleration that changes direction at time t1, because it is moving. If I am moving in this direction, the acceleration is coming, the force is being applied on me on the opposite direction. I will move, and I will stop at one point. Okay, because the force is being acting on me in the opposite direction. After this time t1, what happens? I turn around and I move in the opposite direction, because I cannot withstand the force. I have to halt at one time and I have to come back. All right. So this is how it is depicted. Motion of the object with negative acceleration that changes the direction at t1. That means between times 0 to t1, it is moving in the positive x direction. And between t and t2, it moves in the opposite direction. And at t1, it is having velocity of 0. That we call as the stationary point or turning point, we call as, because it came to halt and turned back. All right. Now velocity time graphs with varying acceleration. Now in this graph you can see the velocity and time, it is varying, right? Now the acceleration is not constant, the velocity is varying with time. It is non-uniform motion. Okay, the velocity is varying with time. When the velocity is varying with non-uniformly, then we call as a what? Varying acceleration. The acceleration is not, it is varying. All right. So in such a case, what we can say, if the rate of variation of velocity is not constant, such motion is called as non-uniformly accelerated motion. It is not only non-uniform motion means velocity is changing, but non-uniformly accelerated motion. It is accelerating with non-uniformly. Okay. So the graph won't be the straight line. The slope of time varies at every instant. You can see here it is theta 1 at this point, here it is theta 2 at this point. The theta 1 is not equal to theta 2. That means the slope is changing. When the slope is changing, the acceleration of this velocity time graph gives you the slope of this velocity time graphs will give you acceleration. As the slope changes, the acceleration changes. So this is about the velocity time varying graph for the motion with varying acceleration. All right. So what is average and instantaneous acceleration? We will study now. Average and instantaneous acceleration. What is average acceleration? Informally we have discussed in our first slide. Change in velocity divided by the time elapsed for the complete journey. All right. So you have started from some point, gained some velocity, there is some final point. So how much change you have done in the velocity from the starting point to the point of reference, that change in velocity, by how much time you took for that change of velocity, that we call as the average acceleration. All right. What is instantaneous acceleration? When the time elapsed, you shrink down tends to 0. When the time elapsed is tending to 0, that means you are concerned about a particular point. You are not no more concerned about the interval, you are concerned about that particular point. So at that particular point, what is the rate of change of velocity? Okay, that is called as instantaneous acceleration. Rate of change of velocity at a particular instant of time we call as instantaneous acceleration. All right. Now slope, simple case, let us see. object with uniform velocity. Now it is a velocity time graph, right? What will be the how will be the motion of the object with uniform velocity? Will it change with time? The velocity does not change with time, right? So it will be somewhat like this. From C to B it is moving with a constant velocity. As the time is increasing, it is moving with 3 meter per second. It is not increasing neither decreasing. That means what? It is under uniform velocity. Now you just take the point B and drop down a perpendicular to time axis. So our concern is, what does this region tell you? What does this region tell you? So what is this region occupied by? It is nothing but the area covered by this line, by the motion of this line. As the velocity is some function of time. Here it is not the function of time because it is moving in the constant velocity. In all other cases, in general case, velocity changes with respect to time where you have acceleration. At that time also, if you see, the area covered under this curve of the velocity of time graph will give you what? This will give, what is this? This is nothing but V. What is this? This is nothing but delta t. This is delta V, this is delta t. So this area will give you what? Delta V into delta t, because this is something called rectangle. Something looks like rectangle. So the does this area will give you? Side into length into breadth. Horizontal axis is delta t. This is the length, and this is the length, this is the breadth. So side into side will give you what? The area. So velocity, change in velocity and change in time will give you what? The displacement, right? So area under the curve of velocity time graph will give you the displacement. So this quantity, the area, this quantity represents the displacement of the object. All right. So let us see area under the curve. Area of OABC is equal to OA into OC, right? Side into side. That gives you change in time into change in velocity. That gives you nothing but this time into velocity is nothing but displacement. You know the relation, displacement is equal to velocity into time. So area under VT curve is equal to displacement. Okay. If the curve is non-linear also, like this also, the area under this curve will give you what? Will give you, this is velocity time graph, will give you displacement. How does the area under this curve you can calculate? You can calculate in this form, right? We have studied the integration. We can do like V dt. What is V dt? It is nothing but distance. Okay, this is, we can write as x. So displacement is the integral of V with respect to time. V dt gives you displacement. So it is not acceleration, it is displacement. All right. If the displacement we want between how much you have displaced it from time t1 to time t2, integral of velocity over dt from t1 to t2, you will get a value and put the time values there and you will get the displacement. All right. So this is about the area under VT curve, that gives you the displacement. All right. So what are the conclusions from this position time graphs and also VT graphs? We have studied all the graphs from position time and also velocity time. So what does the slope of position time graph give you? Slope of position time graph give you the velocity. What does the slope of velocity time graphs will give you? Slope of the velocity time graphs will give you acceleration. And what is the area under Vt time graph give you for uniformly accelerated motion? It will give you that displacement. Alright. So, these are the conclusions from Pt graphs and Vt graphs. So, let us solve some examples and then get familiar with the graphs. Alright. Sarah, so let us solve this example. So, what is given here? We have two velocity time graphs. For suppose this is A, this is B. This is the object A is moving, this object B is moving. Now, we are asked to say which is moving slowly. Okay, where the velocity is moving slowly to reach the destination point. That means what? Intuitively you can think that where it is taking more time to change the velocity. Here you can see the change in velocity from 4 meter per second, it is starting at time t equal to 1 and it is coming to a halt at time t equal to 3 with the velocity of 2 meter per second. So, final velocity is less than the initial velocity. So, it is decelerating. In the same way, here you can see the velocity, the time it is starting at 1 second and it is taking 4 seconds. That means it is coming to a halt at 5th second from 4 meter per second to 2 meter per second, right? From 4 meter per second to 2 meter per second. So, the change in velocity is same in both the cases, but the change in time is how much more for B. Therefore, we can say the deceleration is more. In the other words, we can say the acceleration is more for this, right? Because it is stopping in less amount of time. The change in velocity is happening in less amount of time. But according to our conventional method, we have talked about this in conventional method. Now, let us see via slope. So, this is what the slope will give you. For example, this is theta 1. Okay. This is the slope. So, acceleration of A is equal to tan theta 1. Now, what is the acceleration of B? This is tan theta 2. Okay. This we can easily solve, but our aim is to reduce our misconception on slopes and the way we convey the velocity and speed. Alright. So, the slope of the acceleration of B is what? Tan theta 2. So, you can easily see the steepness is more here, right? Here you can see the steepness is less. That means that theta is more here. Easily you can see, figure out from here, the slantness is more here. So, the theta 2 is more. Theta 2 is more means what happens? The tan theta is more than this one, tan theta 1, tan theta 2. From here, as theta 2 is greater than theta 1, you can also say tan theta 2 is greater than tan theta 1, right? If tan theta 2 is greater than theta 1, that means this acceleration is more. If this acceleration is more, that means it has to come very fast, it has to come to halt very fast, right? Here you know the tan theta 2 is more than tan theta 1, the angle is more. So, tan theta, this slope should be more than this, but conventionally when we solved, it is coming to halt in 2 seconds. But what is the what are we missing here? You all know the tan theta function. The tan theta function, if I draw like this, tan theta function from minus pi by 2 to pi by 2 or from pi by 2 to 3 pi by 2. So, it is periodic from minus pi by 2 to pi by 2, and you can keep on continuing. So it is always an increasing function. If this is minus pi by 2, this is pi by 2, this is an increasing function like this. It is increasing, alright. So tan theta 2 is greater than 90 degrees, right. So if you take here also the same thing happens. Instead of taking this, you can take pi by 2, here 3 pi by 2. So as it is more than what, 90 degrees. So from 90 degrees is starting, as it is, so theta 2 is greater than theta 1. Now you can see, for example, theta 2 is greater than theta 1, you just this is theta 1, for suppose this is theta 2, this is theta 1, this is theta 2, because theta 1 is greater than theta 2, okay, and it is greater than what, 180 degrees, is greater than 90 degrees. Now what is this point? This is nothing but pi, this point is nothing but pi. You can see at what point it cuts, tan here, at what point it cuts, somewhere here, okay. So the value is, which value is more, which value of tan is more, tan theta 2 is more. So here the tan theta 2 is value what, the change in by change in this, right, opposite by adjacent. What is the opposite change? 2 by what, 4, right. 2 by 4 is what, how much, 2 by 4 is 1 by 2, 1 by 2 is 0.5. So this is 0.5 minus. Now what is the slope here? What is this length? 4 minus 2, 2. What is this length? 2. 2 by 2 is what? 1. So it is 1. So theta 1 is 1 and theta 2 is minus 1. Theta 2 is minus 0.5. Now as we discussed earlier, you need to consider about the speeds, not the direction, right. Here it is moving with minus 0.5 what? It is moving with minus 0.5 acceleration. It is moving with 1 meter per second square acceleration, and it is moving with 0.5 meter per second square acceleration. Again listen, it is coming down. This tan theta value will give you acceleration. 2 tan thetas will give you the values of 2 accelerations, but here tan theta value is more than this. That means logically we have to say that here the acceleration should be more than here if you take the slope of tan theta, right. But when you see the graph, it gives you the negative values. Here the slope will give you the magnitude, the overall magnitude. But in our case, in physics, we will take the minus sign apart. That gives you the direction. Minus and plus sign gives you the direction. The remaining part gives you the magnitude. Okay. So tan theta will give you the overall magnitude minus 0.5. But we are concerned about this 0.5, not minus 0.5. Minus gives you the direction, whichever direction it is going, but it is having some acceleration with this magnitude. Right, whether something is fast or something is slow, we will only know about the magnitude, right. So here you can say it is coming down by 1 meter per second square acceleration, it is coming down by 0.5 meter per second square acceleration. When you attach minus, this tan theta will become more. But in physics we don't attach minus for the magnitude, we attach minus for the direction, alright. This is the basic misconception we need to understand. Okay. So this is about this problem. Now let us go to the next problem. This is the two graphs, one is distance time graph, one is displacement time graph. Which of the graphs is not possible? By looking at this, which of the graphs is not possible? Pause the video, look at this graph and come up with the answer. I guess you have already got the answer. Basically what it says that as the time is increasing, the distance is changing. Here you can see the distance is increasing, and from at this point, for example, this is t1. After t1, you can see the distance is decreasing. Is there any explanation? Can the distance be decreased from some value? We have already studied the distance is increasing function. It cannot decrease. Once you start traveling, you keep on traveling. Once you go, for example, 10 meters, once you travel 10 meters, you cannot travel 9 meters after that. That means you cannot say have traveled 9 meters after that. That means here see, you have increased your time, you have increased your distance as time is increasing. After that, what happens? The distance is decreasing. There is no way the distance can decrease, right? Displacement can decrease because it is a change in position. By definition, it is change in position. Change in position can increase or decrease because we are concerned about the initial and final positions. But distance is a travel, your travel. You cannot decrease your travel as you are moving. Any direction you are moving, as long as you are moving, your distance is being increased. Your distance is increasing, right? So this graph is correct. This graph, we cannot have this graph, all right? So this is the thing. Your third one. This is the position time graph. We have studied in the slides. Now you may have the doubt, when you have a curve, how can we identify whether the acceleration is positive or negative or something, right? Simple trick. If you have a concave up, the acceleration is positive. If you have concave down, acceleration is negative. If you have a graph like this, given like this, what happens? It is concave. What? This is concave. Concave up, acceleration is positive. Concave down, acceleration is negative. So here what does it? It is concave down. Concave down means acceleration negative. Okay. Now you see whether the velocity is positive or negative here. This is position time graph. Velocity is positive or negative here. You can see it is any tangent you draw here, it is greater than 90. Greater than 90 means what? Negative, right? So velocity is negative. So acceleration is negative, velocity is negative, speed will increase, as we discussed. So if you are asked from the position time graph to calculate velocity time graph, how we can solve? Let us see. So have you noted down? This is if you have concave up, the acceleration of this object movement is positive. If you have the concave down, the acceleration is negative. All right. You can use your mathematics also. Here you can see the tan theta is changing from how much? How it is changing? From 90 to 0. So tan theta from 90 to 0 means it is decreasing, right? So it is the velocity is what it's happening? Sorry, from 92 it is moving 180. It is not 0, right? You can draw any tangent here, it is more than 90. So 90 to 180 it is increasing. So as the tan theta is increasing, what? The rate of velocity is increasing, that means it is positive. Here you can see from 90 it is moving to 0. At every point the slope is what? Becoming 0. So at this peak point velocity is 0. Velocity is 0 at this peak point. From here it is keeping on what happening? Decreasing. All right. So that is the reason acceleration is negative. So let us solve an example where we are given like this position time graph and you are asked to find velocity time graph. All right. See. Now let us say this is the time where we just call as a turning point. Okay. Now what is happening here? Just see. Here it is concave up or concave down? Concave up. Therefore acceleration is positive. Okay, let us see from here to here, T naught, T1, this is T2. Okay, from here to here just see acceleration is positive for the whole motion. From here to here, if you see the velocity is what? At any point the velocity is above 90 degrees. This. Now here the theta 1, here that theta 1 is greater than 90 degrees here. So what happens? Velocity will be what? Negative. So acceleration is positive, velocity is negative, what? Speed decreases. Alright. So the velocity is becoming negative. Now here what you can see? Here the velocity is positive, right? Here the velocity is positive, as you can see. Still the acceleration is from here to here. Let us see, from T0 to T1, this is. From T1 to T2, what is happening? From T1 to T2, what is happening? The acceleration is still positive. The velocity is what? Positive. The acceleration is positive, velocity is positive, speed is increasing. Alright. So how the graph should be? From T0 to T1, the graph should be negative. Alright. At T1, what happens? The velocity should be 0 at T1 because it is turning point. Here you can see it is minima, right? At minima the slope will be 0. That means here the velocity should be 0 at T1. At T1, v is equal to 0. Okay. So you have to think that from T0 to T1 the graph should be negative. It is going towards positive. Alright. So graph should be somewhat like this. If a graph like this, if this is T1, it is increasing. It should be like this. This is T0, for example, this is T0. So between T0 and T1, velocity is negative. At T1 it is 0. After T1 it is what? What is happening? It is increasing. You can see the speed also. Speed is decreasing. See the magnitude here. The magnitude is decreasing and it reached 0. And at this point it is a turning point. And now here acceleration and velocity are in same direction. So the speed will increase. The magnitude. This is velocity. This is time. So at T1 the velocity is 0. Once again, as the position is coming to T1 from T0 to T1, okay, what happens? Acceleration is positive, velocity is negative, speed decreases, speed is decreasing. Velocity is negative, in this code velocity is negative, right? Now it should be positive here as after T1. After T1 velocity is positive, acceleration is also positive, so speed increases. So if you are asked position time graph, this is how you will calculate the velocity time graph at each given period of time. Alright. So we have completed all our graph sessions. Position time graph we have studied, velocity time graphs we have studied different types of motion, and we have studied non-uniformly accelerated motion and uniformly accelerated motion. So in this session we have basically covered all the parameters that need to define the motion. Alright. Now we have to define how the motion is changing. That means what equations govern the motion, what equation govern the motion. So using these parameters, let us derive some equations of motion in the next session. That will be even more interesting and thrilling session. So until then, I hope you will recap all the concepts we have studied till now, which will be useful in the next session. Till then, thank you. Sai Ram.